God bless you, math analysis students. This will be a practice video, and I perceive I'll have to do 2 videos to cover all that we have to practice and be ready for the upcoming quiz, already coming up on Thursday. So, do you remember this? If you can believe, all things are possible to the one who believes. If you can believe, nothing's impossible to the one who believes. What's too hard for God? Did he not make the sun, the moon, and the stars, the heavens and the earth? So if you can believe, all things are possible to the one who believes. Nothing's impossible to the one who believes. Even challenging math problems become possible once we believe. Not believe in God, I trust we all do, but believe that we can do it with God's help. And so let's go ahead and dive in with number 1. Well, let's go ahead and take a look at first things first. I think it's number 7. Number 7 says, write a scripture which can help you to approach difficult math or life problems with confidence, knowing that it is possible for you to find a solution. So here's the answer. If you can believe. All things are possible. To the one or to him who believes. I trust you'll apply this truth to the questions that we have to do. All right? So let's go ahead and start with the first one here. 1a, it says factor out the greatest common factor for each. This should be from each expression. So here we got 4x squared minus 12x. And we look at this expression and this one, we say, oh, 4 can go into both. And also x can go into both. So we factor out 4x as the greatest common factor. And what will be left? We say 4 times what will give us 4x squared. This is going to be x. And then 4x times what will give me back 12x. It's going to be -3 to get back -12x. So that would be the answer there. 4x is the greatest common factor, and x minus 3 would be left. How about 1b? 1b is a slightly different looking question. This whole thing here can be considered a term, this cluster, and this another cluster. And so we say what's common to this and this. And when we take a close look, we see, oh, 2x plus 1 is common to both. You should put that in parentheses. When you factor that out, and you say 2x plus 1 times what will give me back this? But it's going to be times x. And then you say 2x plus 1 times what will give me back this? And it's going to be times a plus 4. So that would be the answer for this one. The 2x plus 1 is common. and what's left here will be x plus 4. Here we're going to do some more factoring, and whenever you see 4 terms like we've got here, 1, 2, 3, 4, you should be thinking what? Did I hear someone say grouping? Yes, that's what you should be thinking. So you put group by 2's, x cubed minus x squared, make that a group of 2's. And here it's a little bit tricky because you got a minus here. And if you put a minus on the outside, watch carefully, you've got to remember that this is understood to be minus 1. So what goes in here cannot be plus anymore. It has to be a minus 5. And you say, why? This is plus. Yeah, but watch carefully. A negative 1 times a negative 5 will give you back the plus 5 here. So you have to be careful when you start to group with a minus before your second group. Now we have to take out a common. What's the greatest common factor out of these? From the first grouping, it's going to be x squared. What would be left would be x minus 1. From the second group of 2's, we have a 5 common. What would be left here is an x minus 1 as well. And you know you got it right when you've got the same thing here, x minus 1 as you have here. And now again, somewhat similar to what we did over here, we're going to consider this whole cluster as a term and this whole cluster as a term. And we say, what is common between these two circled clusters? It's going to be x minus 1. So we say, okay, x minus 1 comes out. And what's going to be left from this cluster when we take that out? So it will be x squared. And what will be left from this cluster would be minus 5. So that would be the way to factor this expression using grouping. Similarly, you could do this one. And I'd like you to just practice with this one by yourself. Okay, so this is for your practice. Do it similarly, grouping by 2's, because you got 1, 2, 3, 4 terms. Now number 3. What do we have here? We have factor the trinomial. And so this one is a little bit more involved, where we have 6x squared minus 5xy, and here minus 6y squared. I hope I wrote this down well. But anyway, 6x squared could be a 3x in one parentheses times a 3x in the other. Negative 6y squared could be a 3, let's see, no, I did this wrong. It should be 3x with 2x to get 6x. 3 times 2 is 6, alright? And for a negative 6y squared, I know one has got to be positive, one has got to be negative. And so I got a 3y understood, and then a 2y, that would give me the y squared. But no, one has to be positive, one has to be negative in order for me to get a negative answer. And because the middle term is negative, I'm going to make the bigger one negative, so that when I multiply the 3y with the 3x, I'm going to get a negative, let me put it here, negative 6xy. When I multiply the 2y with the 2x, I get a positive 4xy. When I put these together, I'm sorry, this should be 3 times 3 should be 9. And 2y times 2x is 4x. So negative 9xy plus 4xy, that's going to give me my middle term, which is negative 5xy. So this will go in one parenthesis, and this will go into another parenthesis. So here comes the factoring. going to be 3x plus 2y times 2x minus 3y. Okay, how about this one? Factor the difference of squares. Difference of squares, let me give you the recipe, remind you of the recipe. It's like this: a squared minus b squared is a minus b times a plus b. Those should be the factors. So let's go ahead and express this as difference of two squares. Should be like this: something squared minus something else squared. So here's the question: what squared would be 36x squared? This would be 6x right here. And what squared would be 49y squared? This should be 7y right here. So you can examine that, and I think that's right. And now let's follow the pattern here. This is the template. So this is my a, and this is my b. So the very first term should be 6a squared. That would be this. Sorry, first term should be, let me try that again. Should be 6x minus b. b is this, 7y, so 6x minus 7y. Get rid of that. That's going to go in one parenthesis. And the other parentheses would have the a plus b, which would be 6x plus 7y. That takes care of that one. How about the next one? Factor the perfect square trinomial. So here we have, the perfect square trinomial. Let me remind you of the pattern or the template. It's going to be an a plus b squared, which would be, I'm sure some of you know it, I can rattle it off: a squared plus 2ab plus b squared. So if you look at this as an a squared, I could actually express it like this. Let me see if I can put it here. 25x squared can be expressed as 5x all squared plus this 10 can be looked at as 2 times 5x. It's understood to be 5x times 1. And finally, the b squared can be considered to be the 1 squared. So here's your a, 5x. Here is your a again, and 1 is the b, and then 1 is the b. So here comes the factoring. I'm going to go backwards now. Factoring would be 5x, that is the a, plus the b is 1, and that's squared. So this is the trinomial, and we're going backwards to show the factoring would be that. If you FOIL this out, you'll find that you get exactly that. What else do we have on this page? Let's go ahead and we're going to use the sum or difference of cubes for this. Here comes the pattern for that. This is a sum because it's plus. So here's what the template looks like. A cubed plus b cubed. That will be a plus b as a binomial times a squared minus, shape it minus, the product, which is ab, and then plus b squared. Okay, from this one you might say, what's the a and what's the b here? Watch carefully. The a will be 2x, that is cubed,